हम लोग जानेंगे चर्न प्रिडिक्शन। ठीक है, तो बेसिकली मैं पहले एक्सप्लेन करना चाहूंगा कि चर्न क्या होता है। तो चर्न ऑकर्स व्हेन अ कस्टमर कैंसल्स अ सब्सक्रिप्शन और स्टॉप्स बाइंग द प्रोडक्ट from the company. Then the customer that leaves that company is known as churn. Churn is the leak that companies try to plug. So basically, churn prediction uses machine learning. So basically, with the help of machine learning, we try to predict the churn. So we got to know that what is churn. So churn is basically the customer who leaves the company or they cancel after the subscription. Okay, so machine learning helps to identify this customer behavior. So basically, it means start with the machine learning. Few algorithms are there that we can start with. So today I have taken two algorithms. First of all, logistic regression, and second one is decision tree classifier. Now you must be thinking that why two machine learning algorithm? Why not only one? Suppose, see, we must have to we first of all have to check with the two to three algorithm, because different algorithm gives a little bit different values. Okay, now as we know that SVM perform better on the data set with high dimensions. Okay, whereas the logistic regression doesn't. So just for the comparison purpose between two to three model, and to know that which model perform well. So if the model which performs the well gives the good result, that will be used for the process further process. So now, first of all, we have started with the importing libraries. So we have imported pandas, numpy, mat. Although we don't require any numpy here, because we didn't deal with any of the numerical values here yet, but still if you want you can keep this. And then we have imported matplot for the visualization, and seaborn also for the visualization of histogram as well as box plot. So now other important libraries like pre-processing, label encoder, trend trace split, logistic regression, decision tree classifier, and for the accuracy purpose, like for matrices we have used accuracy score, confusion matrix, classification report, ROC curve. Now, first of all, we will start with the loading data set. Okay. So now you must be thinking that I have taken student performance factors. Okay. No problem, because churn is basically what, like the subscription, like the customer who have left out the purchasing or subscription from the company. Like I'm a customer who have unsubscribed Netflix. So this is the thing. So basically here student performance factor consists of different features that includes attendance, previous scores, hours study. So these things are even the exam score. Now, but this data set does not contain any churn. Now, here the machine, what the this machine algorithm will do is that it will consider 0 and 1 for the value, 0 for not dropout, 1 for dropout. Okay, so here basically we have taken a student performance factor CSV file, which consists of different features that I already told you. And now, according to that, we have made a chart that includes exam score. And by applying the lambda function, we get to know that if a person is get less than 60, then it will be denoted as 0. Means it will be denoted as 1, else it will be denoted as 0. 0 means person less than 60. That means there is a high chance that the student may take dropout. And if score is greater than 16, that means churn is 1. That means the student will not drop out. Okay, so we have this we have made the churn value, because in this student performance vector there is no such churn given. Although there are churn prediction or churn customer called data set called the churn customer prediction, it's already available on the Kaggle. You can download that and use that. But I have taken some another uh, data set. Now we have tried to find out the null value and got the result that I will show you. Now few things that I have taken from the features, like a few features that I have taken out, like teacher quality, and then I have tried to fill out the null values using mod. Even you can use mean, median, mod, forward, backward filling, whatsoever. It's totally on you. Now distance from home, parental, and same as. Now we have tried to feature engineering. So basically feature engineering is the process of creating the new features from the existing one. And feature extraction, but feature extraction is different. Feature extraction is extracting or creating the new features from the raw data. Okay, here what, no raw data, but like there are raw data which consist of null values, too many null values, so we just remove and merge two or three rows together to create a new feature. But here in feature, that is called feature extraction. But in the feature engineering, what we do is that whatever the rows or column are there, we are just calculating or processing over that to make the new features. Like student study efficiency, there is no such column called a study efficiency in the CSV file. So we have made this column, and this is the formula. Same goes for academic engagement, wellness score, race score, etc. Now we have EDA, so basically exploratory data analysis. So basically what happens is it deals with the visualization part. So in visualization we have uses SNS, which is a short form as of Seaborn. Okay, now we have used the count plot, hist plot means histogram, and then we have made the histogram of two to three different columns like attendance, hour study, exam score, and so on. Now we have also made the box plot. So basically always remember that box plot is used to visualize the outliers. Okay, now in this I haven't done anything much with the outliers, though there were only one or two values that seems to be noisy or outliers. That's why I haven't done much more with the outliers. But there are various methods like Z score, IQR, interquartile range, and box plot method to handle those outliers. Okay, but there were only one or two values. That's why that seems to be outlier. That seems to be like outliers. So I didn't done anything with that. But if you want, you can do that. Now we have also made a heat map, and always remember heat map always required the numerical value. That's why we have used a level encoder. We encoded so that we can encode it in the numerical form. Now here we are basically we are doing the then pre-processing part. And now the most important part comes here is the x in the x and y, where x is the one part and y is the another part. So basically x is the features that are the what to say, the model is going to run, and y is the prediction. So basically here you will see that from the model we are dropping churn and examination score, because here we get a concept that here we have made the churn on our own on the basis of examination score, and these two things are being getting stored in the data set. Now if we will leave as it is, then what will happen is that model will learn in the data set output column that should contain churn was no there. So we have initially created a churn on the basis of exam score. Otherwise what will happen is that if we will not drop this, then the model will learn from these things, and then it can easily predict. So there is no sense model will get the shortcut. That's why we have dropped these two columns, so that model will learn the other features except these two, and y column will contain this churn column, where the values will be like 101100. That will be the predicted value. Now from here we have taken the x and y, x train, y x test, y train, y test, and we have split it. We have taken the test size as 20% and the random state for 42%, just because of randomness. Now we have called the logistic regression, and then from the logistic regression we have done saved that logistic regression in the variable lr, and then after lr dot fix x trend and y trend, we will try to predict the value on the basis of x state, and whatever the values we will get, we will try to compare with the y test values and the y predicted value. Just simple. So and then confusion metric classification report, these things we will get. And same goes for the decision tree classifier, and here also we'll get the value, and then we will compare the both model accuracy. Like for LRA, accuracy means logistic regression accuracy, and DT means decision tree accuracy. And after comparing, we will draw both of their graph. Now here is the plotting of AUC, as you can see. Now see, whatever the outputs were there, it has been printed here. Now you can see that. See, now what I said is that in the column, like there were 20 columns, attendance, our study slips, our exam score was one of that. From there we have made Now here you can see that when we have made the when we have done few type of feature engineering, then the new columns has been added up, and then you can see here that a churn column is also there. Now if we will give this value to the model will learn exam score and churn, then the model don't need to go through the y out means y part output part. It will from here only the model will get the shortcut, and it will predict that leads to the biasness of the model. So we don't want these things, that's why we have dropped. Now here this is a churn distribution, and as you can see this is the histogram and count plot which we have made, as well as the box plot here as I said earlier. And this is the heat map. Now heat map consists of, now this consists of nearly 20 features. So now 20 features and the relationship between them are shown. So this map is bit hazy and overlapping, but from there you could go to see the things like, see, our study attendance, like 20 columns, 20 features at the right side and 20 features at the bottom. So it means 20, I mean to say is that 20 feature on the y-axis and 20 feature on the x-axis. So this make it a bit hazy. Now from here logistic regression we get the accuracy of 0.9931, and from the decision tree 0.9924. So as you can see that both are giving the same. Model comparison is also done, so both are same. But yes, depending on the few more factor, we could say that logic based model is here the logistic regression, because logistic regression is 0.9931, here 0.924. So a very slight point difference, that's why the best model here is logistic regression. So that's why if there were the, I could say that the more best the most best model that could be used here is the random forest that uses the ensemble technique. So yes, so these are the things that are done in basically done in the churn prediction part. Thank you.